Alright, John, I'm back. So what I was saying is that there's one cycle of the sine curve in every 2 pi radians. So a cycle just means that, it goes up and then down and then it's just going to start right over, okay? Let's see what else. The period of the sine function is 2 pi. Oops. How on earth did that happen? 2 pi. So period is one of the key vocab words that you're going to have to learn during this chapter. And period just means the length of the interval needed to see one full curve. Okay, so that's something that you're really going to have to remember. I would write that down if I were you, because period is one of the key vocab words that you're going to need to know. The other one's frequency, but I'm going to talk about that a little bit later, okay? So next thing that we are going to do is start taking notes on the cosine curve. So that was sine, now we're going to do y is equal to cosine of x. Okay, so what we're going to do is the exact same thing. I want you to use your unit circle, and we are going to figure out values of cosine between 0 and 2 pi, and we're going to do that at the intervals of pi over 4 again, so 45 degrees again. So up here we're going to have x, down here we're going to have cosine of x, and we are going to go in intervals of pi over 4, or 45 degrees. So this is going to be 0, pi over 4, 2 pi over 4, which happens to be pi over 2, 3 pi over 4, 4 pi over 4, which is just pi, 5 pi over 4, 6 pi over 4, which is 3 pi over 2, we're just reducing that. 6 pi over 4 reduces to 3 halves. So that was 6 pi over 4. 7 pi over 4. And 8 pi over 4 is 2 pi. Alright, so now let me just complete this table really quick. And we can go through our unit circle. So yet again, we are going by intervals of 45 degrees. So you're going to look at your unit circle and we're going to check to see what the values of cosine of x are at intervals of 45 degrees all the way around the plate. So radical 2 over 2 is going to be important again. Okay? So when when x is equal to 0, cosine of 0 is 1. Cosine of 45 degrees, or pi over 4, is radical 2 over 2. Cosine of pi over 2, cosine of 90 degrees is 0. Now we're into the second quadrant, so 3 pi over 4, that's 45 degrees into the second quadrant, so that's going to be a negative radical 2 over 2. Cosine at 180 degrees is negative 1, and you can be using your unit circle to check me out on these as I go. We are now into the third quadrant, so cosine is still negative, so this is negative radical 2 over 2. Cosine at 270 degrees is 0. Cosine in the fourth quadrant is going to become positive again, so positive radical 2 over 2. And then cosine at 2 pi or 360 is 1. Okay, so that's the exact same thing. We went around our unit circle and found out those values of cosine. Now I'm going to make a graph for you so we can see what the picture looks like. So we're going to go between 0 and 2 pi yet again. And we are going to be good mathematicians and label our axes, y and x, with arrows, because you will get points off if you don't do this. And then I'm going to go through and label my axes. So I have 0, pi over 4, 2 pi over 4, which is just pi over 2, 3 pi over 4, 4 pi over 4 is pi. 5 pi over 4. 6 pi over 4 is 3 pi over 2. 7 pi over 4 and 2 pi. Okay, so yet again, the only reason why I'm doing this at such small increments is to show you what the values of cosine are. And yet again, our range is going to be between +1 and -1. X goes between 0 and -2, because that's just standard where we're going to graph between. Okay, so when x is 0, cosine x is 1, so it's going to actually start up here this time. Remember that radical 2 over 2 is really a 0.7. So at pi over 4, we're at 0.7, which is about here. Pi over 2, we're at 0. 3 pi over 4, we're down here at -0.7. Pi, we reach our minimum of -1. 5 pi over 4, we're at 0.7 again. 3 pi over 2, we hit 0. 7 pi over 4, we're at positive radical 2 over 2, so 0.7. That looks a little bit high. And 2 pi, we are up here at 1 again. Alright, so let me just graph a picture of this for you, and it should be like a little bit flat on top, then curve down, then it should be a little bit flat on the bottom, and then curve up again. This certainly is not a V. It does not just go completely down and then straight up again. It's a continuous curve, so make it look like that when you're drawing this, okay? So this is the graph of y is equal to cosine of x. And you can see that it's definitely different from sine of x, but it's the same concept in that it's a continuous curve. So it starts up high, it goes down low, ends up high, and if I had kept going, it would just be like a continuous wave that keeps going off in either direction. It's just that we are only graphing between 0 and 2 pi. Okay? So let's just do the same thing that we did before. Let's divide it out into the quadrants. So you're going to be asked to do this on the test, so make sure that you know how to do this. The first quadrant is between 0 and 90, so between 0 and pi over 2. In this unit, you will be responsible for kind of counting and dividing things out in terms of radians, so you need to be careful of that. So between 0 and pi over 2 and pi is the second quadrant, pi and 3 pi over 2. These are the quadrantal angles, that's where I'm drawing these lines, and then the last one is at 2 pi. So those are our 4 quadrants. I would go through and label them. 1, 2, 3, 4. And you can see how each of these quadrants are also quarter circles. So this one is the first quarter of the circle, that's the first quadrant. This is the second quarter of the circle, second quadrant. Third and fourth. So if you took all of those pieces together and put them together, you'd have the unit circle again. So it's kind of a little bit hard to recognize that on your own, but you know, we're not making this stuff up. It really does come from the unit circle in that continuous wave motion. Okay, so let's come over here and take some notes on the cosine curve. Why do I keep doing that? Okay, cosine curve. Starts at its max, so that's a 1, so it starts at 1. Ends at its max. Goes through its minimum, which is -1, halfway between. And between each max and min, it goes through 0. Okay? Alright, so let's just kind of use those notes really quick to just graph a quick sketch of cosine so I can show you what I mean. Okay, so if I'm going to do this for my homework assignment, I'm just going to draw out my axes, and you can either do this on graph paper. If you don't have graph paper, just grab a ruler and make your axes. So the first time that we did this, I was going at increments of pi over 4. This time I'm just going to go at increments of pi over 2 or 90 degrees, just like I did before. So I'm going to graph between 0 and 2 pi. And this is always how I do it. In between 0 and 2 pi is pi. In between that is pi over 2. In between these two is 3 pi over 2. So you see how it's just so much easier when you only have to label those 4 things instead of all of them. Okay, so let's just use these notes that Ms. Tompkins gave us to draw a quick sketch of the cosine curve. So the cosine curve starts at its max, so it starts right here. It ends at its max, so it ends at positive 1. Goes through its min halfway in between, so at pi we're all the way down here at negative 1. And then in between the max and min, obviously it has to go through the x-axis, so obviously it has to hit 0 here, and it's going to hit 0 here. So look at how easy that is. And now let's just draw that sketch real quick. It's a little bit flat up on top, and a little bit flat on the bottom. Goes up, and you're gonna hopefully be a little bit smoother than me because you're not drawing with a mouse. So that is y is equal to cosine of x. Okay, so write down those notes so that you have them out in front of you. Okay. We also have a couple more notes to go through. Let's see. Let me see here. The last thing that Ms. Tompkins has written down is how to graph the sine and cosine functions on the graphing calculator. Okay, so what we're going to do is we are going to put our calculator in radian mode. And this is really important. This is the only time on your Regents exam that you are going to have your calculator in radian mode. If you have your calculator in radian mode other than graphing trigonomic functions, you will fail the Regents exam. It needs to be in degree mode every other time except for graphing trig functions. So we're going to put it in radian mode. You're going to go to the y equals function, type in whatever function that you have, and we're going to set the window. We're going to set the window between 0 and 2 pi. Oh my god. Why is this doing this? We're going to set the window, between 0 and 2 pi. And then we're going to graph it. So I think that I'm going to do that very quickly with you so that you can see how it looks. So let's go to our graphing calculator and let's just graph, I don't know, the sine function. So we're going to go to mode first and make sure that we are in radian mode. Otherwise this whole thing's going to be completely screwed up. So you're going to be in radian mode and hit equal. So once you do that, you're good. Let's go to the y equals button, clear out whatever else you have in there, and let's just graph sine of x. See what that looks like. That's what we did before. Let's graph sine of x, and then before you hit graph over here, you're just going to go over to the window, and I'm going to set my window. So the x-axis, because we're only graphing between 0 and 2 pi, that's what I'm going to type in. My x min is going to be 0. My x max is going to be 2 pi, and I'm literally going to type that. So 2 and then second pi. Now once you hit enter, it's going to change it to decimal form for you so that you don't have to do that. I'm going to make my y minimum -1 because that's the smallest value that my y can be. I'm going to make my y max a +1 because that's the greatest that it can be, and now I'm going to graph. And it should draw a beautiful sine function for you. And let's just go back and let's graph the cosine function on the same window as well so that you can see what that looks like too. Cosine of x, close those parentheses, and my window is still the same, and that's what it looks like. Which is kind of pretty cool, and you can actually tell that the sine and cosine curve are the exact same thing, but just shifted a little bit. I think it's shifted pi over 2, so 90 degrees in either direction, which is kind of cool. Okay, so I'm going to shut off this video right now and see you soon.